Today we are actually going to find the area under the curve and apply the calculus to that. So we have gone through quite a few things, and I'm going to review what we've done so far. So to find the area under the curve, thank you. Okay, the first thing that we used was an estimation with the Riemann sum. Okay, I'm afraid I'm going to spell this wrong. Is it R-E-I?
Yeah.
R-E-I or R-I-E? All right, I got it right. Riemann sum. Okay. The new packet is for later. Okay, and remember, this is an approximation. Door, please. Thank you. And then what we just completed the other day was the geometric. Man, that seems so long ago, doesn't it? And this is with all geometric shapes. So we did what? Triangles, squares, rectangles, my beautiful drawings here. Oh, we did circles too, right? Okay. Okay. And then what we're going to focus on today is what I showed you in that first example when we found the area under the curve of, what was it, 5 dx, where it was a rectangle. So the area was 60. So this is actually going to be what's called the fundamental theorem of calculus. We've got 1 and 2. Okay, so FTC means fundamental theorem of calculus. FTC is a universal abbreviation. It can be used if you need to write anything about it. Okay? And this is basically where you compute the integral. Okay, and I have already showed you how to do this, but we're going to go through it formally today. And then the last one would be using the calculator, and I'm going to show you that as well. So you do need your calculators today. Okay, so this is area under the curve, and this is everything that we've talked about and will talk about. All right? Okay, so first of all, like I said, when we're talking about the fundamental theorem of calculus, basically what this is saying is you are actually going to use calculus to find the area under the curve using integration. And like I said, this is the FTC parts 1 and 2. It's 3 pages, I think. So the fundamental theorem of calculus, or abbreviated FTC part 1. When you identify this, you don't have to say FTC part 1, FTC part 2. It's just FTC. Doesn't matter. Fundamental theorem of calculus. There's just 2 pieces to it. One of the biggest pieces here is, again, our function must remain continuous on a closed interval. Guys, if your function is not continuous, then everything falls apart. Okay, this is key. Then you can't even use this. So the function must be continuous. And then they're saying that capital F, which distinguishes between the 2 function notations, is any antiderivative, okay, meaning the integral of f on the closed interval from a to b. Okay? So this is what we've got here. You've got the integral from a to b, which means find the area under the curve. This is a definite bound of the given function. What does this note right here? What does that tell us we have? Yeah, you have the derivative. So once you integrate and you find out whatever that new function is, remember you leave off the plus c because it's a definite integral, and then you are going to evaluate the upper limit, which is f of b, meaning whatever that b value is, we're going to plug in for every single x or whatever your variable is in the function, evaluate it, and then you are going to subtract f of a. Okay? You will get here a numerical answer. There will be no variables. And what we are doing here is finding the area under the curve algebraically. We are finding the area under the curve, algebraically. I think I'm running out of ink. Okay. Got it? Couldn't spell. All right, so in plain English, sort of, the definite integral can be evaluated by finding any antiderivative, meaning you're finding the integral of the integrand, meaning what's to the right of the integral symbol, okay, and then subtracting the value of this antiderivative at the lower limit from the value at the upper limit. Okay, so it's always f of b minus f of a. Okay, always f of b minus f of a. All right, so this is what we're going to do. We are going to find the area under the curve of the given function over the stated interval. So what this means when you are asked in the directions to find the area under the curve, you're going to integrate. Okay, you are going to integrate. So you notice here this has no integration symbols. So based on the directions, it says find the area under the curve, okay, of the given function over the stated interval. So actually what I'm going to do is rewrite using integration. Okay, so this is the integral. Oh my gosh. You got to open the door.
Is Mr. Syed?
No. Okay. Okay, so we've got, remember guys, this is the integral from A to B, right here. The integral from A to B, okay?
From A to B.
So remember, if you look up here, A is on the bottom, B is on the top. So we're going from -1 to 1. Is this in the proper order? Yes. My function is x to the 4th dx. They want us to integrate f of x. That's what it's saying. Okay, and we're just going to proceed. So all I did was take this function over this interval and rewrite it because they told us to find the area under the curve. All right, so what is the integral of x to the 4th? 1/5 x to the 5th. No, why no plus c? Because it's a definite integral. That's right. My bad. Okay, MB. That's what you can say, MB. Yes. All right, and we're going from -1 to 1. So take a look here at this notation. Once you have integrated, it's like you straighten out that integral symbol, and this is basically saying you're going to evaluate this function from -1 to 1. Okay? So you take your upper limit and you plug in. So you have 1/5 times 1 to the 5th power minus 1/5 times -1 to the 5th power. Okay, it's f of b minus f of a. Tell me about this value. Is it going to be positive or negative? It's going to be negative, so it's minus a negative, so you're going to combine those two. So what's the area under the curve? That's right, 2/5. Okay, questions? All right, so let's take a look here. We want to integrate, okay, over this interval. So we're going to rewrite this, bless you. We have the integral from where to where?
1 to 5.
1 to 5. And we are going to integrate what? 1 over x dx. Okay, here's my question. What is the integral of 1 over x? Yes, some of you fell for that problem and left that value off. You'll see when you get your quizzes back today. Yeah, So this right here is the natural log of the absolute value of x to be evaluated from 1 to 5. Okay, no plus c. So this is the natural log of the absolute value of 5 minus the natural log of the absolute value of 1. Absolute value of 5 is just 5. What's the natural log of 1? 0. Okay, so if this was a non-calculator question, this is about as far as you could go. The answer is a natural log of 5. You're done. How do you know it's non-calculator? Well, you look at the directions, and first of all, we don't have a calculator out on our desks yet. A lot of you? I mean, I'm looking. Yeah. But also, too, the directions don't say round to 3 decimal places. It kind of gives you a hint. Okay, so that's a sufficient answer. Excuse me. Questions? Yes? Is that a question?
Yeah. So, is it only natural log of 5 and not absolute value of 5? Because
It is the absolute value of 5.
Yeah,
But I went from here. What's the absolute value of 5? 5.
Oh, all right. Okay.
I simplified. I didn't do it here because hopefully you would know that the absolute value of 1 is 1, and the natural log of 1 you have to know is 0. So I was just sort of
Instead of 5, that was like
negative 5.
expression.
Oh, you just leave it.
You leave it?
Well, most of these are going to be values when you're evaluating the definite integral, but there are some where you would have an expression like x minus 1 or something like that. You would just leave it as a natural log of the absolute value of x minus 1. Because you don't know what x is. They'd have to tell you. Make sense? Okay, any other questions? Okay, so here, this is just saying evaluate the integrals using part 1 of the FTC. This is just already set up for you. So I'm not going to, yeah, I am. We're just going to do it all. Why? Because it's not really that hard. What's the integral of 5e to the x dx? 5e to the
x.
Thank you. 5e to the x to be evaluated from the natural log of 2 to 3. Okay, so what we have here is 5e cubed minus 5e to the ln of 2. Okay, so this here would technically be a correct answer, but it's not simplified, and most likely this type of question, the directions would say provide your answer in its simplest form. Can you do anything else to this if it's non-calculator? Well, I'm just talking about this one right here. But yes, you are right, because we're going to move to that one. So this one is pretty much, I can't do anything, right? So we have 5e cubed. What were you saying, Caitlin? Yeah, and this 2 just kind of comes down, right? So the e and the natural log, because this is log base e, go away, and you're left with 5 times 2. So this is 10. So this is actually a property that you need to remember. Did you guys learn that like in Algebra 2, I think? Yeah, which seems like eons ago. It feels like, nah, nothing. Okay? All right. So you might want to go back through that, especially your logarithmic properties. All right, let's take a look here. We need to integrate secant squared. What do I take the derivative of to get secant squared as an answer? Tangent is correct. So we have the tangent of theta to be evaluated from 0 to pi over 4. This is all unit circle. So we've got tangent of pi over 4 minus tangent of 0. What's the answer? It's tangent of pi over 4. It's the easiest. 1. Yes, 1. What's tangent of 0? 0. So the answer is 1. Okay? Questions? All right. So there are some additional examples in your book. I'm sure you guys are going to hurry and just crack that baby open and look at all the examples that are there. Yeah. Okay. So you can humor me. It's quite all right. I know. All right. So let's talk about the difference between area and total area. Here we have area, also known as displacement. We're going to get more into this later. But what you need to remember about just if the directions say find the area, which represents the displacement, this can be negative. Okay, so let's take a look at this graph here. Here, this portion is positive, so you would leave it where it is. And this portion right here is also positive. Oh my. But this portion is negative. And you're going to leave this, if you're being asked just for the area, as negative. And the reason why is when we're talking about just area, which by definition means the displacement, we are talking about the position in relation to where you began. Okay, which means the particle, the car, the person, whatever you're talking about, okay? Now, if the description says find the total area, okay, total area, this is the distance traveled. So can distance traveled be negative? My car's stuck in reverse, but I still need to go to my grandparents' house. Am I traveling in a negative direction? No, I'm just going backwards. Doesn't matter. It's going to be terrible for my car, but that's the only way I can get there. Either that or I'm going to get pulled over first. But the point is that total area, if you look at this graph, it cannot be negative. Okay? So if our function is a continuous function over the given interval, here's that word again, continuous, then the total area between the curve is given by the following. Guys, this is so important because you're going to look here total area, that's the key word. What do you notice here? It's the absolute value. Okay, so what you need to remember is this will be always positive. That was terrible English. Always positive. Okay, so see how if these two are the same graph, they took this area and flipped it up. So it moved up to the top. Okay? Questions? Okay, so total area cannot be negative. Oh my goodness.
I don't, wait, what's funny about it?
I don't know.
What?
I don't think it's